Hello and welcome to a new edition of DevOps World. In this video, we are going to look at three different deployment strategies for Karpenter node pools. Right, the first strategy is all on demand. So what this means is that the Karpenter controller is going to launch 100% of the nodes using the on demand. Right? These are market prices, market rates for on-demand EC2 instances. These are basically going to be the highest cost, but at the same time, you get the highest stability because these nodes are guaranteed to be there. They're not going to be kind of, taken away by a disruption, right? When disruption happens, obviously, AWS will reclaim back if you have a spot instance, but on demand, you are guaranteed to have the instance and you are able to kind of, deploy your workloads onto these EC2 instances without having with guaranteed uptime. So the second deployment strategy is all spot. So here in this strategy, the Karpenter controller is going to deploy your workloads onto 100% spot instances. The good part about it is that you will get these at the lowest cost possible, typically around 70 to 80% discount. But at the same time, you have to know that these are unreliable in the sense that they can be taken away at any point of time. My understanding is you have a 2-minute window before you get a notice that your node is going to be taken away. And within 2 minutes, Karpenter will kind of make sure that your node is drained and all the pods are scheduled onto a different node while this is kind of claimed back. Now, if your workloads are 100% stateless or at least they can sustain this kind of disruption, a 2-minute window, then by all means you should go for spot. You get huge savings if you go with spot. Another more creative approach is to use 80-20 split, wherein 80% of the workloads are going to be on spot and 20% are going to be on on-demand instances, right? So let's say you have a deployment and you want huge cost savings, but at the same time you want to have some sort of reliability that there is no disruption at all. So you can use this strategy, wherein you can have 80% of the pods in that particular deployment go on to spot instances, and 20% be deployed onto on-demand node instances, right? So with this strategy, you get the best of both the worlds. You get both cost savings and also reliability, right? So if you can do this, I would say this is probably the best approach. If you are 100% confident that you can do, your workload can sustain disruptions, all spot, by all means, you get, huge cost savings. If you don't want to bother about all that, of course, you can go with all on demand. So in this video, we are going to look at all three strategies. We are going to have an eye on the cost with each one of these. We'll use the same deployment across these three strategies, and we'll see what the difference in cost is. And that way, I hope you're able to kind of understand the value of these strategies. And also, if you have watched the video until this time, please make sure to subscribe and share this video with friends. And let's move on to the demo. Okay, so let's get started with the demo. Currently, we have a 2-node cluster which costs about $72 a month. So these nodes currently are just hosting the Karpenter controller. We do not want to schedule any workloads onto this. So there are taints already built into these nodes. So you will not see any kind of, EKS workloads scheduled onto this other than the Karpenter controller and other required daemon pods and so on. So what we are going to do is, the first strategy we are going to use is the on-demand strategy, right? So what we have is, let me walk you through what is the on-demand node pool. So we have an on-demand node pool. So this node pool basically is going to only use on-demand, market place, EC2 instances. So we'll do this by deploying this on-demand node pool, and we have something called as an inflate deployment. This inflate deployment is a pause pod. It does nothing, and we are going to deploy this with 0 replicas, and we'll scale it up to 10 replicas. Okay, so we'll do that across all the deployment strategies we discussed in the previous part of the demo. So let's start with deploying the node pool, on-demand node pool. Okay, the node pool is deployed, and then we'll start with deploying the inflate deployment as well. Inflate. Okay, so let's look at what we have here. Now we'll not see a spike in prices here yet because we still haven't done the scaling of the deployment. So let's go and look at the node pool. So node pool got deployed. So this is the on-demand node pool, and we also have the deployment called inflate that we just created. So this is the inflate deployment I just showed you. So now I'm going to scale this to 10 pods. So let's see what happens. So once this is scaled to 10 pods, you will see Karpenter trying to launch on-demand nodes. And what we have done is we kind of have a topology spread factor between zones. So it's actually going to launch in 2 availability zones. So let me show you that. If you look at this deployment, you should see the topology zone spread here. So max skew is 1, which means that you have to have no more than one different pod between the 2 availability zones. So if one has 3, the different availability zone cannot have 5. It can, if one zone has 3, the other zone should have either 3 or 4 or 2. Okay, so that's what it means. So let's look at the cost now. The cost spiked up to $349, or let's round it to $350 a month. And we just want to verify that all the nodes are, all the pods are completely running. So let's make a note of this price. So this is $350 a month. So now let's tear down this deployment. So let's first scale the pods down to 0. And then we'll change the deployment strategy, and let's delete this deployment, the node pool. Let's delete the node pool. We'll delete this node pool, and then wait for the nodes to be reclaimed. Meanwhile, let me show you the Spot node pool. So now we are going to do the Spot node pool. It has everything exactly the same as the on-demand node pool, except that the tag here is basically Spot. So you should basically, Karpenter should only look for Spot instances. So let's deploy this, and let's see what happens. Let's create a Spot. Okay, so a Spot node pool has been created. So let's look at that Spot node pool. So the node pool is ready. It has no nodes yet. So let's look at the deployment back here. So we have we have 0 pods. So we are going to scale up this deployment now, and all our previous on-demand nodes have been reclaimed. So we are back to $72 of operating the cluster. The cost we noted was $350 for on-demand. So let's scale this to 10 pods and then see how the Spot looks. So as you can see, Karpenter is spinning up on spot instances we can see that the cost is significantly lower. From 350, you're looking at around hovering around 195 over here, 195 a month. So you're looking at $150 saving on purely spot instances. So let's wait for this to settle. And then the next strategy we are going to use is a combo strategy, the 80-20 split. Okay, so this went well. So all the pods are scheduled and our cost as noted is around 195. So let's scale this back to 0 pods. 0. And then let's delete the on-demand deployment as well. Let's delete delete the spot deployment, spot node pool, sorry. So we delete the spot node pool. Now what we are going to do is now I need to explain a little bit how to do the 80-20 split. So we'll actually go ahead and delete the inflate deployment as well. We'll use the same inflate deployment but with different tagging. So let's delete this and let me explain what we're going to do. So here let's look at the combo. So we are going to create the combo node pool. So let me walk you through the combo. So this is what we are going to use. Okay, so the combo has two deployments. One is the on-demand deployment and the other is the spot deployment over here. But what's important here is the capacity spread. If you look at this key over here, it is 2, 3, 4, 5. So what Karpenter is going to do is when it looks at something like this, right, it actually kind of uses this as a weightage, and here it's 1 over here. Okay, there's a capacity spread and the requirement here is 1. So what Karpenter is going to do is when it looks at this, it creates capacity spread labels onto the nodes that is going to launch here on node pools, and then it will use it as a weight factor to distribute the pods. For example, if there are 10 pods, based on this distribution, it distributes like 20% of the pods into the on-demand node pool and 80% of the pods into the spot node pool, right? And we have slightly kind of used the same inflate YAML. It's the exact same thing. It's just that we change the topology spread constraints here to use capacity spread. Okay, so it's the exact same thing. Let me look at it side by side so you can see what we are doing. So this is the inflate deployment. This is the inflate deployment. It's called split. We call it inflate. It's the exact same thing. There's no change. The only change is the topology spread constraints. Here we were spreading across zone. Here in the earlier two deployments. Now we are going to spread it as a capacity spread between node pools. Okay, so let's get started. So let's deploy the combo node pool first, and then we'll see what happens. Combo node pool. Okay, and as you can see, it deployed two node pools. One is an on-demand and the other one is a spot, and then we'll create the split deployment, which is again the same inflate, okay, so it's the same inflate deployment, but it uses the topology spread differently. Now let's scale. So let's look at the cost. So cost here, now if you were tracking this video, first the cost was around 350 on purely on demand, and on spot it was around 195. Now we are looking at a combo. Let's scale this to 10. We're going to do the same thing across all the deployments. So let's do scale this to 10 and see what happens. Now just watch this and see the spread. So it kind of launched an on-demand node, and it basically kind of launched a few spot nodes, right? So now it's trying to spread the load around. while what's happening in the cluster. So we'll just be watching both. So, okay. So we see 2 on-demand nodes and a few spot, 1, 2, 3, about 7 spot nodes, 1, 2, 3, 4, 5, 6, 7, 7 spot nodes and 2 on-demand nodes. And the on-demand has 3 pods, 4 pods. Yeah. So it's spreading the pods around. Some of them may be daemon pods, so you can ignore that. So it's spreading the pods around between on-demand and node. And these were the cluster nodes. So they were there earlier, these 2 over here on the top. And these are the new nodes that came up. You can see 2 on-demand nodes and the rest are spot. And all the workloads have been scheduled. And you can look at the cost. The cost is around 289. So let's do the math here. Okay, so let's do a calculator. So the math is we have 350 for let's say on demand, plus we got 195 for spot. So we get 2 and divided by let's say 2, it's 272. We are looking at 289. So this is somewhere in between. Okay, it's slightly a little bit higher, but it's somewhere around in that range. So here the good part is you get reliance in terms of on-demand nodes being here, and you get spot cost savings as well. And your capacity and your cluster is again as responsive as it can be, because these are all kind of same type of nodes, as you can see. And one is a different one. This has 5 pods. So this spot is I think slightly bigger, but it got it at the same price. So anyways, I hope you like this video. So you can use any strategy that fits your business needs. If I personally, I've used a spot, a combination of spot and on demand 80-20 split, and I find it very good in terms of a right sort of balance between cost savings and performance and reliability. So it's your call how you want to use it, but I hope this video was helpful. If you like the video, please subscribe to the channel and share the video. And I'm always looking forward to comments. Please make sure to comment. Thank you.